In today's short video, we are going to see a very important fact that in Newtonian mechanics there is no ultimate speed of a particle. It means you can say that in accordance with Newtonian mechanics, a speed of a particle v may be infinity. Okay? Now let us try to explain this fact. We consider a particle of mass m, and that is lying at the origin of our coordinate system at time t equal to 0. Let us consider a constant force F is impressed on the particle in x direction. Since the force is applied in x direction and particle is initially at rest, so motion will be along x direction. Okay, that is, its motion will be a one-dimensional motion. And as you know, in one-dimensional motion there is no need to write the vector form of equation of motion that will be equivalently equal to the scalar form. So now let us consider, after impressing the force, the particle moves along x-axis and at any time t, it reaches to this point P where its velocity or speed becomes v. We consider. Okay. Now let us write the equation of motion of that very particle. So what will be the equation of motion? The equation of motion of the particle will be F equal to dp by dt. This is actually Newton's second law of motion. You can see that I have not written the vector form because motion is one-dimensional. And so you can say that this is this implies F equal to d dt mv, because momentum p is equal to mv. And in Newtonian mechanics, you know that mass of the particle is constant, so this will be m dv by dt. And as you have to find the velocity v at any time t, so you can see that this dv will be equal to what? This will be f over m dt. Okay? And therefore, for getting the value of v at any time t, let us integrate this result. So dv will be equal to f over m dt. And the limits will be 0 to t for time t, and for velocity it will be 0 to v. So after integrating, you can see that the velocity of the particle at any time t will be what? This will be simply f over m into t. You can see that this velocity of the particle or speed of the particle, you can also say speed, is a linear function of time t. Here f and m both are constants because we have assumed that force impressed on the particle is constant. So the graphical plot of v in against of t will be just a straight line. Okay. Now you can see that as the time increases, velocity v will increase linearly. So if you can say t tends to infinity, it means you are impressing the force for infinite time, then this velocity v will also tend to infinity. So you can see that in Newtonian mechanics, velocity may be infinity. So there is no upper limit on the velocity or speed of the particle in Newtonian mechanics. And so we simply say that in Newtonian mechanics, velocity of a particle may be infinity. Okay, thank you very much.